Okay. All right. Okay, remember yesterday we calculated compound probabilities. What's compound mean? More than one event. Okay, but it was independent events. Today, after this, we're going to do dependent events. So here is a scenario. Okay. Let's consider a compound event comprised of more than 2. Okay. So how many events are happening here? 3. How many times are we flipping the coin? 3 times. Okay. So first flip, second flip, third flip. That's 3 events. Okay. Are the events independent events?
No. Yes.
Yes.
It's one, man.
How do we know?
Because it's 2 events.
Yeah, but why are they independent? Why are they not dependent?
Because there's 3 different flips.
3 different flips. Does the coin change magically in the air after the first flip?
No.
No, you still have the same chances on your second and third flip. You agree?
I agree.
Yes. Okay. Next question. What is the probability that all 3 coin flips land what? Heads up. So how many fractions should I have? 3. Okay, what's the first flip? What's the first fraction?
1 over 2.
1 over 2.
Times 1 over 2 times 1 over 2. That's 18.
Okay. Do we all agree with the fraction?
We can agree.
Okay. How do we multiply fractions? I know.
Multiply cross.
Go cross 1 times 1 times 1. 2 times 2 times 2.
6. No, make it 12. 8. Who's the 8, bro? That.
Okay.
I'm talking about 2. I'm talking 6. And then you simplify that. Or no, you can't.
Yeah, this one is simplified a little bit. Okay. Alright, so sometimes you will have 3 events, and so just heads up, your ISO might have that. Okay. Alright. This time they're changing the scenario as well. Okay. This time, what does it say? What's the probability that the first 2 coins are what? Heads up. And the third coin lands tails. Which is my fraction look like?
So 1 over 2.
1 over 2. And then? 1 over 2, yeah, right.
Yeah, because it's 1 and 1, it don't matter.
Right. What about the third flip?
1 over 2.
Yeah. Okay. And why doesn't it matter? Because what kind of event is it?
Coin.
Independent. It's a coin. Okay? It's the same chances every time. So it's still 1 over 8. For those 3 compound events. Okay? Alright. Let's move on.
Yes.
Go down. That would be part D.
Huh?
Okay, this is where it's important that we know how to read and understand what we're reading, because if we can't read, we can't do math. So, what is the probability of the second coin landing what? Tails up. Did they say anything else? No. But how many events are happening? 3. So, what is the first event?
2 over 3. No?
Did they say any condition for the first event?
Okay, no.
So what should my fraction be? Let's start with how many options do I have on a coin? 2. What do I want to happen for the first event?
1.
Did they say anything for the first event?
No.
So then what are my chances for the first event?
0.
How many sides? Good. Okay. Because reason being, you're confused. They didn't tell me what the first event needs to be. So I have a chance, it doesn't matter, I can get heads or tails 2 over 2. Okay? But you did give me a condition for the second event. What did it need to be? Goes up to the top fraction.
1 over 2.
Good.
I told you 1.
We all have smartness. Okay. Okay, what about the third event?
1 over 2. Nope.
Did you give me a condition for the third flip?
So 2 over 2.
2 over 2 again. Because I could get heads or tails, doesn't matter. They don't care what the first and third flip is. They just want to up. Let's make this easier. What is 2 over 2? Over 3. What is that equal? 1. Remember that? Everything divided by itself is 1. 1 times 1/2 times 1. Anything times 1 is just the same number. Okay. Because if I multiply 1/2 one time, I still have 1/2. Okay. Alright, you're going to try the next one. What is the probability of flipping heads on the first coin and tails on the third coin? Good, because what is the condition for the first flip?
What?
Getting heads, right? Okay. What did they say about the second flip? Riley. Right? Can you give me a condition for the second one? No. So what should the fraction be? Good job. 2 over 2. 2 over 2, which we already know, that's going to simplify to what? 1, yeah. Okay, and then the third coin, what is the fraction? Y'all tell me. 1 over 2, getting tails, 1 over 2. Good. Okay, look up here. Listen. 6 period. Focus. Focus.
Dynasty, bro.
Okay, 1 times 1 times 1 is 1. And then 2 times 2? 4. 4. Okay. Good job. Okay, let's switch our brains to dependent events. So, it's still compound, there's still more than one thing happening, but now it's dependent. So, here's the scenario. You have, your paper, you have 2 red, 1 blue, and 3 green socks in a drawer. So how many total? 6 socks in a drawer. Except somewhere over here, you don't get 6 socks. Okay? Suppose that you reach into the drawer without looking and you choose a sock, you put it back, and then you choose another sock. So actually, is this dependent or independent? If you put the sock back, independent, okay? So, everybody okay with that scenario? Okay? Let's go to dependent. So let's get a character card. Part 2, number 2. Number 2, go to number 2. Go to number 2. Let's read it this time. Number 2 is different. Number 2 says you reach into the drawer without looking and you choose a sock. So you do not replace it. That's what that. Now, what kind of event is it? Dependent. Because you didn't put it back. You kept it. Okay? And then you chose another sock. Okay? So just remember there's 2 red, 1 blue, 3 green. Okay, can we start the problems now?
Yeah.
Okay. We already answered this. Is this dependent or independent or was it? Dependent because you didn't put it back. Okay? Read it?
Yeah.
Okay. Part B, number B. Everybody well dependent? Okay, part B is do a tree diagram. Can I trust you that you are good with tree diagrams?
Yeah.
Good. Okay. Okay? It says, before we do a probability problem, how can we figure out how many outcomes we have for this dependent scenario using this fundamental counting principle? Okay, think about the first event is choosing one sock. How many options do you have when you first choose the first sock?
Three.
What's the total?
Three.
How many socks is there? Six. So remember, you just want outcomes. When it's outcomes, you just looking at how many choices you have. So the first event you have 6 options. But how many options do you have in the second event since you kept the socks? 5. So how many possible options are we going to have for all these scenarios? 30 options. Okay, this is just a refresher from the previous lesson. Okay. Alright, now let's do the probability. Ready? Ready? Yep. Calculate the probability of choosing a blue sock and then a red sock. Okay? I'm going to model this one with you. You're going to do the next one by yourself. Okay? So, the first event is choosing what color? Blue. How many blue is there? 1 out of 6. Okay? Event D is choosing what? Red. Okay? How many red socks is there? 2. But, what did we do with the first one? 5. Good job. Okay? And because of the fundamental counting principle, what do I do with these two events? Multiply. Good job. 1 and 2. Over 30. Can I simplify? Absolutely. By what number? By 2. Divide by 2, the top and the bottom. Remember, when you simplify fraction, you have to divide the same number.
That's 1.
1 over 13. Okay? Oh, wait. Hold on. Okay. You're doing a red sock and then a sock that is not blue. Ready? And probability for choosing a red sock from the drawer. So that would be event A. Jesus, what was the probability of choosing red first? Just the first fraction. How many are red? 2. And then how many are there in the drawer? Yeah, 2 over 6. Okay, are we good with that part? Okay, and then with the second event, choosing a sock that is not blue. Not blue. So how many are blue? How many are blue? In the drawer. 1. So Dylan, can you give me the probability of choosing something that is not blue from the drawer? After, listen, keyword is after you already chose the red sock. What is the fraction, Dylan? 3 over... Wait. Can you explain how you got 3 over 4? Just so I can... Mm-hmm. But we only chose one red one. not quite. It is over 5 though. Everybody agree it's over 5? So let's talk about it. So there's 5 now because we already picked one, right? We kept it. But it's asking something that is not blue. But we already took a red one. So how many red ones are left?
1.
1 because we took one the first event.
4 or 5.
And then how many green ones is there? 3. 1 plus 3?
4.
4. Okay. Let me explain that again because this one was tricky, I will say. So the first season was choosing a red sock. Everybody was good with 2 out of 6. Okay. But when you do the second event, it changes because this already happened. What happened in the first event? What did it choose? Red. So what socks are in the drawer now? There's 1 red, 1 blue, and 3 green, which is 5. Does everybody understand where I get 5? But out of those 5, how many are not blue? Well, there's 1 blue, so how many are not blue? 4. For the second event. So you have to remember, you have to pause and think, what already happened? How does my sample space change? Okay. And then we just go across. 2 times 4? Oh, sorry. Good job. 8 over 30. Okay. What's the highest number both of these divide by? 2. Good. This gives me refraction. 4 over 15. Okay. Okay. Let's do this one together. Ready? We can get that. The probability of choosing 2 socks with the first sock being green. Okay? So, the first sock being green, that's the first event. Okay? How many green socks is there? 3 out of 6. Okay, first event happened. Do I care what the second event is? No, not from this one. They just said 2 socks, but the first one has to be green. So then, how many are in the drawer? If you already picked the green one, how many are in there? 5. And out of those 5, do they care what color I pick? No. So I can choose 5 out of 5. Any of the 5 out of the total 5. Because go across 3 times 5. 15 over 30. That should be an easy fraction.
5.
Higher. 15. 15. Divided by 15.
You think there were 5? You just want that.
I'm sorry, it's on the bottom. So let's go to the back. Sorry. Okay. Right. Where are we? Alright, let's talk about, here's the rule, okay? Here, this is the rule, it's in your notes. It's what you just did, but in math words. So, it's right here. This is called the conditional probability. The vocab, okay? You have to know that word, conditional probability. What is conditional probability? It's what I just told you. It's calculating event A and B, but this bar right here He's given. Please put an arrow there and write given. So if I read this out loud in mathematical language, so I'm going to do this so that people in the back can see.
He went to twice what happened.
Reset. Okay, sorry. I'm going to read this out loud. The probability of A and B. What kind of events do these have to do to you? Equals the probability of event A times the probability of event B given that what already happened. The first event. Okay? Alright. I did it. You have this top 2. Work on the